Hello, welcome to Nightlight Science Stories. Close your eyes and imagine looking up at the night sky in the year 1676. The universe is a clockwork mechanism, perfect and instantaneous. When you look at a star, you believe you are seeing it right now. But one man is about to look through his telescope and discover that the universe has a delay. His name is Ole Rømer. He is a Danish astronomer sitting in Paris, obsessed with the moons of Jupiter. They are perfect cosmic timekeepers, eclipsing behind the giant planet with flawless regularity. Until they don't. Rømer notices something strange. When Earth is moving towards Jupiter, the eclipses happen a few minutes earlier than predicted. When Earth is moving away, they happen a few minutes later. The clocks of the heavens are drifting. The scientific world is baffled. Is Jupiter's gravity fluctuating? Are the moons speeding up and slowing down? Rømer has a wilder, more terrifying idea. The moons are perfect. It's the information that is late. He realizes that light is not instant magic. It is a traveler. And like any traveler, it takes time to cross the massive distance between the planets. He calculates the delay. He realizes that when Earth is on the far side of the Sun from Jupiter, the light has to travel an extra distance, the entire diameter of Earth's orbit. That extra distance takes about 22 minutes. It was the first time anyone had ever put a number on the speed of reality. Light wasn't infinite. It was just incredibly fast. About 220,000 kilometers per second, according to his rough calculations. It was a staggering number, but it was a finite number. The universe had a speed limit. This discovery shattered the ancient view of the cosmos. If light takes time to travel, then when you look at the stars, you are not looking at the present, you are looking at the past. The night sky is a fossil. You are seeing Jupiter as it was 40 minutes ago. The Sun as it was 8 minutes ago. And the nearest star, Proxima Centauri, as it was over 4 years ago. Rømer didn't just measure speed. He discovered that telescopes are time machines. We are forever trapped in a delayed broadcast of the universe. But the scientific community was slow to accept this. For centuries, light was thought to be instantaneously everywhere. It was almost spiritual. To assign it a speed was to drag it down into the mud of physical reality. It would take another 50 years for another astronomer, James Bradley, to confirm Rømer's findings by looking at the slight shift in star positions as Earth moves. By the 19th century, the question shifted. If light is a wave traveling through space, what is it waving in? Just as sound needs air and ocean waves need water, surely light needed a medium. They called it the luminiferous ether. The ether was hypothesized to be an invisible, weightless substance that filled all of space, through which light waves propagated. It was the fabric of the cosmos. And if Earth was moving through this ether, we should be able to detect an ether wind, just as you feel the air rushing past a moving car. This sets the stage for the most famous failed experiment in history. Two American physicists, Albert Michelson and Edward Morley, built a device so sensitive it could detect the slightest shift in the speed of light caused by this ether wind. They floated their apparatus on a pool of mercury to eliminate vibrations. They rotated it, expecting to see light slow down when traveling upwind against the ether and speed up when traveling downwind. They measured and they measured again. The result was shocking. There was no wind. No matter which way they turned, no matter how fast Earth was moving around the Sun, the speed of light was exactly the same. The ether did not exist. This was a catastrophe for 19th century physics. How could light travel without a medium? And more importantly, how could its speed be constant regardless of the observer's motion? If you run towards a sound wave, it hits you faster. Why doesn't light behave the same way? The universe was breaking the rules of common sense. It required a new mind to see the solution. A patent clerk in Switzerland who was about to realize that if the speed of light is constant, then something else must be flexible. Something we thought was rigid. Albert Einstein realized that if the speed of light, t, is a universal constant, immutable and absolute, then space and time themselves must be willing to bend to accommodate it. He proposed that as you move faster, your clock ticks slower and your ruler gets shorter, just enough to ensure that whenever you measure the speed of light, it always comes out to exactly 299,792,458 meters per second. The speed of light was not just a number. It was the central pillar of reality. This is the foundation of special relativity. Light is not the guest in the house of space and time. It is the architect. Space and time are woven together into a flexible fabric called space-time, and the speed of light is the loom on which it is woven. We have moved from a universe of instant magic to a universe of rigid rules. But why this specific speed? Why not faster? In the next part, we will enter the modern particle accelerators to ask the question, what happens when we try to push matter to this ultimate limit? The Large Hadron Collider, buried 100 meters beneath the border of France and Switzerland. Here, we don't just observe the universe, we try to break it. In this 27-kilometer ring, we accelerate protons to speeds that numb the mind. We push them to 99.99% of the speed of light. They are traveling just 3 meters per second slower than a photon. You might think, we are so close, just a little more push and we break the barrier. But this is where the universe reveals its great trap. To bridge that final gap, to close those last 3 meters per second, requires not just more energy, but an impossible amount of energy. As we pump energy into the protons, something strange happens. They don't just go faster, they get heavier. This is the dark side of Einstein's famous equation, E equals mc. Energy equals mass times the speed of light squared. It means energy and mass are interchangeable. When you feed energy to an object to speed it up, that energy has to go somewhere. At low speeds, it becomes motion. But as you approach the speed of light, the rules change. The energy you add stops making the object faster and starts making it massive. At 99.9% light speed, a proton is 22 times heavier than it is at rest. At 99.99999%, it is thousands of times heavier. The faster you go, the heavier you get. The heavier you get, the harder it is to push you faster. It is a cosmic feedback loop. To reach 100% of light speed, your mass would become infinite. And to move an infinite mass, you would need infinite energy. This is why the speed of light is not just a traffic law. It is the asymptote of reality. It is the wall where the math blows up. There is not enough energy in the entire observable universe to accelerate a single grain of sand to the speed of light. The barrier is absolute, but this raises a haunting question. If nothing with mass can reach light speed, then how does light itself do it? How does a photon travel at 299,792 kilometers per second without becoming infinitely heavy? The answer is simple and profound. Photons have no mass. They are ghosts. Because they weigh nothing, they don't have the option to move slower. They are born at the speed of light and they die at the speed of light. For a photon, there is no acceleration. There is only instant, maximum velocity. This lack of mass is the ticket to the cosmic highway. But for us, creatures made of heavy atoms, bound by gravity and mass, the highway is forbidden. We are the slow walkers of the cosmos, forever trapped in the slow lane by our own substance. But what if we could go that fast? What if we ignored the energy requirements and just looked at the experience? This brings us to the phenomena of time dilation. As you approach the speed barrier, you are not just gaining mass. You are trading time for space. The faster you move through space, the slower you move through time. It's a zero-sum game. At the speed of light, time stops completely. If you could ride a photon, you would experience no time passing between the moment you left a star and the moment you hit a human eye a billion years later. For a photon, the journey is instantaneous. The universe has zero depth. Birth and death happen in the same zero moment. But for us, the observers, that photon took a billion years. We are watching a movie that the photon thinks is a single frame. This relativity of time is not theoretical. We use it every day. The GPS satellites orbiting Earth are moving fast enough that their internal clocks tick slower than the clocks in your phone. If engineers didn't program the satellites to compensate for this relativistic time difference, the entire GPS system would drift by kilometers every single day. Your map would be useless. You are navigating your way to the grocery store using the bending of time itself. It is a sobering thought. The reliable ticking of the clock on your wall is an illusion. Time is elastic, stretching and compressing depending on how fast you run. We have hit the energy barrier and we have seen time begin to warp. But there is one more consequence of the speed of light that is even more visually terrifying. What would you actually see if you moved at relativistic speeds? Sci-fi movies show stars streaking past the windows. But the reality is much stranger. The universe would literally warp in front of you. The field of view would crush together. This is called relativistic aberration. As you speed up, the photons from behind you can't catch up, and the photons in front of you hit you harder. The entire sky would appear to shrink into a bright point of light directly ahead of you. You would be flying into a tunnel of blinding light, with darkness closing in from behind. The universe would look like it's fleeing from your presence. In the next part, we will visualize this journey and ask, what happens to the color of the universe when you run towards it? We have talked about mass and time, but what about sight? If you were sitting in a spaceship accelerating towards the speed of light, the first thing you would notice is not the speed, but the color. The universe would begin to change its palette. This is the Doppler effect, the same phenomenon that changes the pitch of an ambulance siren as it rushes past you. When an ambulance moves towards you, the sound waves are squashed together, creating a higher pitch. When it moves away, they are stretched out, creating a lower pitch. Light behaves exactly the same way, but instead of pitch, we perceive frequency as color. As you rush towards the stars in front of you, you are smashing into their light waves. You are compressing them. This turns the light blue. The yellow stars turn green, the green stars turn blue, and the blue stars turn a deep, violent violet. This is called blue shift. Conversely, the stars behind you are fleeing. Their light waves are being stretched out as they try to catch up to your ship. They shift towards the red end of the spectrum. The universe is splitting into two distinct colors, a cool blue future and a warm red past. But this show is beautiful only for a moment. As you continue to accelerate, the compression becomes extreme. The light waves ahead of you are squashed so tight that they shift out of the visible spectrum entirely. The beautiful blue stars disappear. They haven't vanished. They have become ultraviolet. And then, as you go faster, they become X-rays and finally gamma rays. The view ahead of you goes pitch black, but it is a deadly darkness. You are flying into a storm of high-energy radiation that would cook your ship in seconds. The silence of the void is actually a screening wall of energy. While the colors shift, The geometry of the universe also begins to warp. Imagine walking through a gentle rain. If you stand still, the rain falls straight down. But if you run forward, the rain seems to hit you in the face. It looks like it's coming from in front of you. Light does the same thing. This is called relativistic aberration. As you move closer to light speed, the photons that should be hitting the side of your ship seem to be coming from the front. The field of view begins to slide forward. This creates a phenomenon as the Searchlight Effect. The entire visible universe, every star and galaxy around you, begins to crowd into a smaller and smaller window directly in front of your ship. It is like looking through a tunnel that is rapidly shrinking. The stars behind you don't just turn red. They expand and fade into the darkness as their light spreads out too thin to see. You are becoming blind to the past. The universe is wrapping itself around you, trying to hide in your forward view. At 99.9% of the speed of light, your world is a tiny, blindingly bright disk of radiation directly ahead. The rest of the sky is absolute black. You are seemingly alone in a void, chasing a single beacon of energy. This is the searchlight view. The universe hasn't moved, but your perspective has warped it into a singularity. You are flying through a tunnel of your own making, guided by the twisted laws of relativity. Now let's take the final step. Let's imagine we break the laws of physics and actually become the photon. We hit 100% light speed. What do we see? We see nothing. For a photon, time does not exist. The concept of travel is meaningless. A photon emitted from a star a billion light years away and absorbed by your eye experiences those two events simultaneously. It is born and it dies in the exact same instant. From the photon's perspective, the universe has no depth. The dimension of space in the direction of travel shrinks to zero. It doesn't go anywhere. It is simply there. The billions of years of journey that we measure are, to the photon, a literal non-event. This is the ultimate paradox of light speed. It is the boundary where existence becomes two-dimensional. To travel at light speed is to exist everywhere along your path at the same time. It is a state of omnipresence within your own trajectory. This timelessness is why light can carry information from the beginning of the universe without aging. The light from the Big Bang, the cosmic microwave background, is still streaming through space today. To those ancient photons, the Big Bang is happening right now. We are bathed in the ghosts of the past, kept fresh by the suspension of time at light speed. The universe is a museum that preserves itself by sending its exhibits on a journey at the speed of causality. But there is a strict rule in this museum. You can look, but you cannot touch. You cannot overtake the light. Because if you did, if you went faster than light, you would be outrunning the causality of the universe itself. You would see the glass shatter before you dropped it. This brings us to the final and most impenetrable barrier: causality. In the next part, we will explore why breaking the light speed barrier isn't just an engineering problem. It is a logical nightmare that would unravel the fabric of history. We live in a universe governed by a strict sequence of events. You flip the switch, and then the light turns on. You drop the glass, and then it shatters. The cause must always precede the effect. This is called causality. It is the bedrock of logic. But in relativity, this order is protected by the speed of light. In fact, physicists often say that $C$ is not really the speed of light at all. It is the speed of causality. It is the maximum speed at which 2 points in the universe can talk to each other. Imagine the sun suddenly vanishes. Gravity travels at the speed of light, just like photons. So for 8 minutes, Earth would continue to orbit a ghost. We would feel the gravity of a star that is no longer there. The news of the event hasn't reached us yet. This delay prevents paradoxes. It ensures that the effect, Earth flying off into space, cannot happen before the cause, the sun disappearing, arrives. The speed limit keeps the timeline in order. But if you break the speed limit, you break the order. To understand why, we must look at simultaneity. Einstein proved that now is not universal. Two observers moving at different speeds will disagree on the timing of events. What I see as happening now, you might see as happening in the future. Normally, this disagreement is small. But if you could move faster than light, you could travel to a frame of reference where the effect happens before the cause. You could see the glass shatter before you pushed it off the table. Physicists map this using the light cone. Imagine a graph. The vertical axis is time, the horizontal axis is space. Light travels at a 45-degree angle. Everything inside the cone is your possible future. Everything outside the cone is elsewhere. Elsewhere is the forbidden zone. It contains events that are so far away that light hasn't had time to reach them yet. To go there, you would need to move faster than light. And if you enter the elsewhere, you step out of the ordered flow of time. If you travel faster than light, you are technically traveling backwards in time relative to some observers. This leads to the tachyonic anti-telephone paradox. Imagine you have a device that can send FTL signals. You could send a message to a spaceship moving away from Earth. They could relay that message back to Earth instantly. Because of the time dilation and the geometry of spacetime, the reply would arrive on Earth before you sent the original message. You could send a message to your past self saying, "Don't send this message. If you receive it and obey, you never send it. But if you never send it, you never receive it." The loop collapses. The universe chokes on its own logic. This is why most physicists believe FTL travel is impossible. Not because of engineering limits, but because it would allow you to murder your own grandfather before you were born. The universe seems to have a built-in protection against insanity. There are solutions in general relativity, like wormholes or warp drives, Alcubierre drive, that try to cheat this. They move space around the ship instead of moving the ship through space. They create a bubble where you are stationary, while the universe moves past you. But even these cheat codes run into the causality trap. If you use a warp drive to outrun a light beam and return home, you can still arrive before you left. The math allows it, but logic forbids it. It is a stalemate between our equations and our understanding of reality. So the speed of light is not just a speed limit for objects. It is the structure that keeps the universe from happening all at once. It is the cosmic frame rate that separates cause from effect. Without it, history would be a jumbled pile of events with no narrative. We are trapped in the now, sliding towards the future at exactly 1 second per second. We can look at the stars and see the past, but we can never touch it. The glass wall of $C$ keeps us safe in our own timeline. But there is one thing that happened so long ago that its light is everywhere. It is the echo of the beginning. While we can't travel faster than light to see the future, we can look deep enough to see the moment the clock started ticking. The universe is filled with a fossil light. It is not from a star, but from the fire of creation itself. It is called the cosmic microwave background. We will tune our eyes to the oldest light in existence. We will look at the afterglow of the Big Bang, which is the ultimate reference frame for the universe. We are about to see the baby picture of the cosmos. We have explored the limit. Now let's explore the origin. The speed of light is the reason we can still see the ghosts of the first atoms. You have likely seen the edge of the universe in your living room. Between the channels on an old analog TV, about 1% of that dancing static snow is not interference from Earth. It is a signal from the beginning of time. You are watching the afterglow of the Big Bang. This is the cosmic microwave background, CMB. It is the oldest light in the universe, streaming through every point in space, including your body right now. To understand it, we have to go back to a time before stars, before galaxies, even before atoms. For the first 380,000 years after the Big Bang, the universe was a hot, dense soup of plasma. It was opaque. Light couldn't travel more than a tiny fraction of an inch before hitting an electron. The entire cosmos was like the inside of a thick, glowing fog. Photons were trapped. They were prisoners of the heat, bouncing endlessly in the dark. But as the universe expanded, it cooled. And then, a miracle happened. The Great Decoupling. In a cosmic instant, the temperature dropped enough for electrons to bind with protons, forming the first hydrogen atoms. The fog cleared. The universe became transparent. For the first time, light was free to travel. Those first photons, released 13.8 billion years ago, are still traveling today. Originally, they were blindingly bright visible light. But as they traveled, the space they were traveling through expanded. This brings us back to the Doppler effect. Because the universe is expanding, it stretches the light waves traveling through it. Over billions of years, that primal white light has been stretched so much that it has fallen off the visible spectrum entirely. It has become microwaves, invisible to our eyes, but visible to our radio telescopes. The sky is technically blazing with this ancient fire, but our eyes are not tuned to see it. If they were, the night sky would not be dark. It would be a uniform glow. In 1964, two radio astronomers, Arno Penzias and Robert Wilson, built a sensitive antenna. They heard a constant hiss. They thought it was pigeon droppings on the machine. They cleaned it, but the hiss remained. It came from everywhere, day and night. They had accidentally discovered the CMB. They were listening to the fossilized scream of the birth of the universe. It was the ultimate proof that the Big Bang actually happened. We are living inside the cooling embers of a great fire. When we map this light, we see a baby picture of the cosmos. The tiny fluctuations in temperature, differences of less than a degree, are the seeds of galaxies. The blue spots are where matter collapsed to form stars. The red spots are the empty voids. We are looking at the blueprint of our own existence. Because of the finite speed of light, we can never see now everywhere. We can only look deeper into the then. The farther we look, the younger the universe gets. This creates a horizon. Just as a ship disappears over the curve of the Earth, there's a limit to how far we can see. We cannot see past the opaque wall of the first 380,000 years. It is the curtain drawn across the nursery of time. The speed of light sets the boundary of the observable universe. There are galaxies beyond this horizon, but their light hasn't had enough time to reach us since the beginning of time. They are lost to us, perhaps forever. The CMB also acts as a cosmic reference frame. By measuring how the light is slightly warmer in one direction and cooler in the other, we know that our entire galaxy is rushing through the universe at 600 kilometers per second towards a mysterious gravitational anomaly called the Great Attractor. We are drifting on a cosmic river, measured against the stillness of the ancient light. The speed of light gives us our coordinates in the void. We have looked at the outer limits, the speed of light, the time dilation, the cosmic horizon. But the most disturbing limit of light speed isn't out there in the stars. It is right here, inside your own skull. The speed of light is fast, but it is finite. And the speed of electricity in your nerves is even slower. This means there is a delay in your own processing of reality. You are not seeing the world in real time. You are seeing a delayed broadcast constructed by your brain. We will turn the camera inward. We will ask, if we are always living in the past, does the present even exist? We are about to cross the final frontier, the speed of thought. The universe is waiting for you to catch up. We have traveled from the moons of Jupiter to the edge of the Big Bang. We have learned that light takes time to travel. But the most unsettling journey is the shortest one. It is the journey light takes from your phone screen to your retina, and then the electrical signal takes to reach your visual cortex. We assume we are seeing the world live, but the physics of light speed dictates that live is impossible. There is always a gap, a latency. The now you are experiencing is actually a memory that your brain has just finished constructing. Look at your own hand. Light bounces off your skin and travels to your eyes. That takes about 3 nanoseconds. It is a tiny delay, but it is real. You are never seeing your hand where it is. You are seeing it where it was 3 nanoseconds ago. This means you are forever trapped in a bubble of the past. If the sun disappeared, you wouldn't know for 8 minutes. If your hand disappeared, you wouldn't know for a fraction of a second. You are always chasing the reality that has already moved on. But the speed of light is the fast part. The slow part is you. Once the photon hits your retina, it turns into a chemical signal, then an electrical pulse. It has to crawl up the optic nerve to the back of your skull. Neuroscientists estimate this processing time is about 80 milliseconds. Your brain needs time to buffer the data, color correct the image, and stabilize the shaky camera work of your eyes. You are living life on a permanent tape delay. Your brain is a master video editor. It cheats. For example, light travels faster than sound. When you see someone clap their hands from across a room, the light arrives before the sound. But your brain holds the video track, waits for the audio track, and then plays them together so they feel synced. It manufactures a coherent present that doesn't exist in physics. It lies to you to keep you sane. The reality you perceive is a post-production render, stitched together from outdated information. This creates the flash lag effect. If you see a moving car, your brain anticipates where it should be and projects it forward in your mind's eye to compensate for the lag. You are literally seeing the future position of the car, predicted by your brain, to hide the fact that you are living in the past. We are walking through the world assuming we are interacting with it in real time. But we are actually interacting with a simulation running about 1/10 of a second behind reality. We are ghosts haunting our own lives. The speed of light is the ultimate barrier to connection. It means that we can never truly touch the now of another person. When you look into someone's eyes, you are seeing a ghost. You are seeing who they were a moment ago. We are all isolated islands of time, separated by the sea of causality. We send signals across the void, words, glances, touches, but they all take time to arrive. We are always shouting across a canyon of time. But there is a beauty in this delay. Because light takes time to travel, the night sky is a time machine. If light were instantaneous, the sky would be a boring snapshot of the present. We would only see the stars that are alive today. But because of the delay, we see the history of the universe spread out before us. We see stars that died millions of years ago, still burning bright in our sky. The speed limit allows the past to survive. It allows memory to exist in the form of photons. Einstein showed us that the speed of light is the cosmic speed limit. But perhaps it is better to think of it as the speed of reality. It is the pace at which the universe renders itself. It is the refresh rate of existence. We cannot go faster because there is no faster. To go faster would be to outrun the story. We are bound to this speed, anchored to the present moment by the heavy chains of causality. So the next time you look up at the stars, or look at your own reflection in the mirror, remember the delay. You are never alone. You are always accompanied by the past. The light you see is a messenger that has traveled across the void, just to touch your eye. The present may be an illusion, but it is a persistent one. And in that delay, in that tiny gap between the event and the perception, is where we live. That is where we dream. We have reached the end of our journey at the speed of light. We have explored the limit, the energy, and the illusion. Thank you for traveling with us through the delays of the cosmos. If this journey changed how you see the world, please subscribe and turn on the notification bell. We have many more stories to tell, and we want to make sure they reach you in due time. Good night, and keep watching the dark.